How to graph y equals x cubed. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. The cubic function. Start with the graph grid. We'll need to make a table. And the 7 values that we like to use seem to work pretty well here. So 3 cubed would be 27. And so right now, go ahead and pause the video and complete the table. These are the values you should have received. So what do you notice about these ordered pairs? Think about it. We'll come back to that later. So let's go ahead and plot the points. So 2 over 2 up 8, 1 comma 1, the origin, -1, -1, -2, -8. You'll notice that these 2 points can't easily be plotted, so we will omit those. But we got 5 good points, I think. But what does the graph look like here? Is it like a straight line? Well, to figure that out, we'll go ahead and try 2 other values, 1/2 and -1/2. So when you cube 1/2, a half times a half times a half, 2 times 2 times 2 is 8, so that's 1/8. And when you cube -1/2, an odd number of negative factors will yield a negative answer, -1/8. So plotting that, a half comma 1/8 and -1/2 comma -1/8 really flattens the curve around there. So let's go back to these here. Let's look at those 2 points right there. And I colored them in. Look at them on the table and in the graph. 2, 8 and -2, -8. Look at those 2 points. And then the half and -1/2. Look at those 2 points. And these two, we say that these points are symmetric about the origin. That's the phrase we're going to use, symmetric symmetry about the origin. And even the large ones would have that. 327 and -3, -27 would have that. Connecting the points, y equals x cubed, the cubic function. Again, notice that the curve is flat here. Let's consider some terminology. The origin on this graph is called the point of inflection. Point of inflection is where a curve changes concavity. So it goes from concave up in the first quadrant to concave down in the second quadrant. Half of a smile in the first quadrant, half of a frown in the third quadrant. So we're ready to do the x cubed dance. So we will start off with the point of inflection at the origin. And from there, we'll go right 1, up 1, because 1 cubed is 1. Right 2 and up 8, because 2 cubed is 8. Left 1, down 1, -1, the quantity cubed is -1. And -2, the quantity cubed is -8. So left 2, down 8. And that's the x cubed dance. Go ahead and draw the curve. Remember to flatten around the origin. And that's what that looks like. Domain and range. Let's go ahead and look at those. So here we have a table here with 5 values. And let's go ahead and look at the graph for the domain. So it goes in both directions there. For each x value, there is a y value above or below it. So the domain seems to be all real numbers. which we write as that script R, fancy R. The range, looking at the y values here, it looks like every y value has an x coordinate to go with it, so the range is all real numbers, also that fancy script R. So the domain and the range is all real numbers for this function right here. Where can you find the cubic function in the world? Well, we thought this was kind of clever, found it here with this image right here. And we invite you to interact with another video in this series.